All right, wonderful people, let's get started. So today we're going to factor functions with 1, 2, 3, or even 4 degrees. We're also going to recognize special cases in factoring and how to factor them. All right, so let's go ahead and look at what we got. So different types of factoring. Some of these we've already covered, like for instance, the greatest common factor, or as I like to call it, reverse distributive. So we all know distributive property. We know that in distributive property, you give something to all of the numbers in the group, right? So if there's a group, you give something to everybody in that group. But with reverse distributive, you're doing the same thing, but instead of giving numbers, you are taking them. So let's look at both of these numbers and see what we can take from both of them, right? So I want to take something from both of these numbers. What does 12 and 10 both have that I can take away? So, well, let's see what they have. They're both even numbers, so they should both easily be divisible by 2. So, let's see what happens if we go that way. So 2. And then divide 12 by 2. But actually, we can take some other things too. We don't have to just take numbers. We can also take the variables. So in this case here, I have A2. Because what you have to do is you have to look for the most that you can take from anybody, which in this case here is A2. Because if I try to take A3 or 3 A's from this guy, yeah, he can pay that, but this guy cannot. Since this guy cannot pay, it's not fair for both of them. So I'm gonna have to take 2 from this guy and let's see, divide this guy by 2, or take a factor of 2, because remember this is 2 times 5. 2 times 5 makes 10, so take the 2, you are left with the 5. And he had an A square, but it's gone now. And then check this to make sure that there's nothing else you can take. So you want to take the greatest common factors. So in this case, there are no more. So that's the answer for that one. So let's go ahead and try this one here. So in this one, what can we take from these two groups? So let's look at the number. Well, we only have 2 terms. We have this right here, and then a second term over here. So let's see, we can, 14 and 7 are both divisible by 7. So I'm gonna take a 7 from both of them. But let's also look at what else we can take from both of them. So let's see, look at the m's. So 8 m's and 2 m's. So the maximum I can take away is 2 m's. So m square. And now to the n. So 5 n's and 2 n's. So again, I end up having to take 2 of them. And I have to put the parenthesis here, okay? We're not dividing. We are removing factors. So this is not dividing. We're not just gonna divide both numbers, okay? So I know that's something that a lot of students do. They just divide both sides and they think that's the end of it, but no, it's not at all what we're doing, okay? We're trying to split these numbers apart, but it's like taking something apart, like a machine. If you're taking a machine apart to fix it, you make sure all the parts are there, but you don't remove anything, okay? Everything's gonna be there so you can put it back together. So let's go ahead and take this apart, basically. So 14 divided by 7 is 2. And let's see, we had 8 m's and we took 2 away. So remember, this is the property where if it says you should divide them, then you subtract them. So 8 minus 2 is 6. 5 minus 2. So take 5 minus 2, that's going to be 3. And now for this one here, 7 divided by 7 is 1, but we don't really need 1 there. So let's see, m square, all right, we take an m square, n square. All right, so it looks like we actually lose everything in this group. There is nothing left. Now we can put the 1 in there because there is nothing left. Now I get a lot of people that will put 0 here. but it's not 0 because if you put a 0 there, then it's not reversible. You can't go back, right? Because I need to be able to multiply both of these by my outside number to get my original number back. Okay, so on to the next one here. So the next one here is a difference in squares. So what is a square number? So a square number are numbers that you multiply two of the same factors to get. So for instance, 1 is a square number because it's 1 times 1. 4 is a square number because it's 2 times 2. Continuing this pattern, 3 times 3 is 9. And then 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36, and so on. So you're going to end up with quite a lot of numbers. And I'm going to put a few more on here just so that way you can, just so you can get a clue of what perfect square numbers are. And these are just some that I put here so that way you can easily recognize them. So it kind of helps to have them shown. And in this case here, so we have a rule. So with this rule, the rule is, so your first number is, a square number. So here I have a square. And it says difference. So remember, difference is subtraction. So a square minus b square. So first number is a square number minus another square number. And by the shortcut, I mean that you should be able to just basically follow this pattern and be able to get your answer essentially. So you break it into two groups of that first number. Now you have to take the square root of it because here it's squared. So you have to unsquare it here. And that will be the same on both of these numbers here. And then the same thing here. If you have a number here, you unsquare it, which means basically you take the square root of it. So take the square root of b squared, you get b times b. And it's just a shortcut because you can use FOIL. You can use the same techniques that we've always been using in FOIL of first outside, inside, last, or any of the other methods for factoring that we've covered for quadratics. So let's go ahead and work on this first one here. So 9 is a square number, right? That's on the list. 49 is also a square number. Since both numbers are square numbers, that means that we are dealing with we got to check to see if it's a minus as well. So it is a minus, so that means that we are going to have to use difference of squares. Now we can start off by drawing our double bubble. And now we unsquare 9. So 9, we unsquare it, which means to take the square root of it, which is 3 and 3. 49, oh wait, hold on, I almost forgot the x. So x squared, that is also an x number. So x squared would be x times x. And for now, I'm going to kind of ignore the sign, but it will be a plus and a minus. 49 square root is 7. So 7 and y squared is going to be, well, if we unsquare it, it's going to be just y if we take the square root of it. So 7y, 7y. All right, and then again, I'm going to put the signs in there. And you can put the signs in there. I just wanted to make sure that you understood that we had to take the square root of both the first and the last number. So there we go. It's all there. If you want to check it, go ahead and use your FOIL to check it. Make sure it all matches out. All right, let's move on to the next one, number 4. So 72 is not on our list. And 2 is not on the list either. So can we use difference of squares for this one? Well, that's a trick question because it's yes. Yes, we can. Because we can use greatest common factoring to factor out another number. So 72 divided by 2 would be 36. And 2 divided by 2 would be 1. Now, if I look at just what's in the bubble, 36c to the 4 minus 1, 1 and 36 are both square numbers. So that means I can take the difference in squares. So square root of 36 is 6. C, so I have c to the 4, but remember this is power, so c to the 4 means I have 4 c's. So if I split them into two groups, that'd be c square, c square. Because remember, again, when you divide them, you are actually subtracting them. And then, because this is a minus, I'm going to go ahead and throw in the sign. So we have a plus and a minus, and the square root of 1 is 1. Now, don't forget this 2 here, because this 2 is part of the solution. It's part of the answer. I can't just be taking numbers off because I need these numbers. If I multiply them back together, I should get my original. So if you leave the 2 off, then it's not completely factored. All right, so let's move on to number 5. And let's see, 7 is not a square number. And 28 is not a square number, so neither of those numbers appear on our list. So this would mean that we should probably try the same thing that we did with number 4. So let's go ahead and factor out 7. And let's look at the m. So m, and I only have one m here, so I'm going to take one m from both groups. And n, so I only have one n right here. And that's going to give me, let's see, m, and we took one of the m's away, so that'd be m to the 6. Oh, and the 7 divided by 7 is where that one went. And then here we have n, so the n is gone, so we have no more n. And then m, oh wait, hold on, n is gone too because we took the n, so there's nothing left there. Minus, and let's see, 28 divided by 7 is 4. And m, let's see, the m is gone because we took the m out. And n to the 3, which we took 1 out, so there are 3, but we took one of them out. So that would be 2. Now from here, we check to see if this can be used with the rule of difference in squares, which it looks like m to the 6. Now 6 is not a square number, but actually any exponent that is even is a square number because I need 2 of the same number to multiply it to get m to the 6, which there is a set that we could use, and that would be m to the 3. M to the 3 times m to the 3 will give us m to the 6. Okay, and moving on, we know that there's going to be a plus and a minus sign, right? Because that's what it says, that's what it tells us to do. And now let's see, 4 is a square number because it's 2 times 2. And n square is a square number. I mean, it says it in the name. And again, don't forget anything you factor out has to stay with all the numbers. All right, there we go. We're done with that one. Moving on to number 6. Okay, so let's go ahead and let's see, 10 is not a square number. So it looks like we are going to have to take out something. We're going to take out a factor. So let's see if we can take out 10. And they both have a w. So, and again, you got to go with the lowest one. So this guy has only one w, so we can only take 1 away from any number. So that'd be 1, but we don't really need the 1 actually. So he had 2, or he had 5, but we took 1 out. So remember, we're taking numbers away. And here, let's see, for the second one, we have 10W. So take out the 10, take out the W, and it looks like we are left with 1. So we can probably factor this now. So don't forget the first number. So I'm going to put the first number here. Okay. I just wanted to make sure that I was clear about taking out the first number and putting it out front. So W square minus 1 and W square, plus 1. And are we done? No, actually we're not done. Looking at this a little closer, well, I'm going to switch the directions here. So I'm going to switch the plus so that it goes first. Now, if you look closely, there's actually a second difference in squares here. W square minus 1. So be careful because 1 is a square number. So anytime you're looking for square numbers, don't forget to look for 1. I'm going to run out of space here. So W plus 1 and W minus 1. All right, that's what it's going to look like. But actually, just to make this a little bit easier to read, I should probably, oh well. But anyway, yeah, that's W plus 1, W minus 1. There wouldn't be any more room for me to write it if I did try to redo it. All right, so that is the first type, and that is a difference in squares. All right, moving on to the next one. Now here's where it starts getting a little complicated. The sum of cubes. So you know what squares are, but let's see if you know some cubes. So some perfect cube numbers are numbers that you multiply 3 of the same number. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Let's see, 4 times 4 times 4 times, only 3 times is 64. 5 times 5 times 5 is 125. And let me go ahead and put some other numbers in there. And so on. So they probably won't get much higher than that. So a sum of cubes looks like this. We are adding one cube number to another cube number. So sum, again, means adding cubes. So a cube number and another cube number. So again, just like with the squares, it helps to have a short list of perfect cubes so that we can recognize them. So x to the 3, that is a cube number because it is x times x times x. 27 is a cube number because it is 3 times 3 times 3. So let's go ahead and break down the rule right here. And in fact, this one here has a bit of a more complicated rule because it's going to look kind of like that. In a previous lesson, we did the 1, 2, first, middle, last technique. And it is the same thing. It is the same thing if you were to multiply. So like 1, 2, first, middle, last. Right, so we multiply 1 times the first, 1 times the middle, 1 times the last. And then we do the same thing, 2 times the first, 2 times the middle, 2 times the last, and then we add them together. And again, this is the same thing, all right? That's why we have so much stuff coming from a little binomial like this. All right, so let's go ahead and apply the rule. So again, we're gonna have to kind of do a little bit of uncubing. So A, let's see if I can make an easier way to do this. A equals, and we uncube it. So take the first term, which in this case is x to the 3, and we take this basically like the cube root. We take the cube root of it. So what 3 numbers multiply to x to the 3rd? Well, just x, because x times x times x is x to the third. And our b value for the formula, 27, we unsquare that. So again, we kind of know that it's 3 times 3 times 3. So a is x, b is 3. So hopefully I have enough room in here because I won't be able to take it out. A minus b. So a minus b, so that's x minus 3, because this is my a, that is my b. Now we square a. So a squared is x squared minus a times b. So minus x times 3. So x times 3, x3, or if we put it in the right form, it would be 3x. And last one is b squared. So b squared, so that means 3 times 3. So that would be 9. And there we go. We're done with that one. On to number 8. So let's see. Let's check for square numbers. So m is a square number, and 216 is a square number. So since it's on the list, we're able to count it out. So 1, 2, 3, 4, 5, 6. So in this case, b is 6. So our b value is 6. And this term is also paired with it, so it has to go with it. So that'd be 6n. A was a pretty easy one. That's why I didn't really bother with the A. Oops, got some lag or something going on. So A value is m. So again, take the cube root of m to the 3, you get m. Take the cube root of, so cube root would look something like this. If you need a calculator, you could probably put something like that in there. In fact, you know what, let me go ahead and see if I have a calculator that I could use in case you need it. You know, you need to know what the cube root looks like. So let me go ahead and switch over to calculator. And let's see if I can find the cube root. I think some simple calculators like this do not have the cube root. I have square root, but I don't know if I'm able to change the index. So I don't believe this is going to work. Now, you do have another option, and that option is to go to Desmos. So let's say like you get a number that's not on the list, or something that's really, really big. So just type in Desmos. And now we are going to find the cube root. So in this case here, let's just stick with the example that we had earlier, and that is 216. So we have root, but I'm unable to change the index. It's only square root. So what you would have to do is go to functions, scroll over to the last tab, miscellaneous, and here you have n power root, or in index root. So this allows you to type in your own index. So in this case, I want cube root. And in fact, I don't really need this here, so I'm going to take that out. And I'm going to punch in 216. So this tells me that it is going to be 6. It doesn't graph it, but it also works as a regular calculator. If you are not sure how to do this, and you don't have Desmos, which if you're watching this, you most likely have access to Desmos because, well, it is what it is. So what you can do is pick numbers that you think it might be. 5 times 5 times 5. So there you go. And that gives me 125. We could try, like for instance, 7 times 7 times 7. And that would be 343. 6 times 6 times 6. There you go, so 3 of them. And that would give you 216. So if you don't have a smart calculator, you're just gonna have to times numbers 3 times to see what you can get. All right, so that was a quick lesson on how to use some calculators. Let's go ahead and fill this in. So A minus B, so A is M, minus our B value, which in this case is 6N. Now we're going to go ahead and start on this one here. So A square, so we have our A here, so that's M. M square minus AB, so MN. So that means this times this, right, M. So we want to put it in alphabetical order. So 6MN plus B square, 36N square. And there we go, we're done with that one. All right, number 9. 500 is not on the list because 512 is the closest number we get. And we can't really adjust it. You know, we can't adjust it so that we get 512 and 500 because that would cause that, you know, that would be like a really, really small decimal number, like 0.00 something something. So I don't think we're going to be able to change that, but we're going to have to do the same thing we did with some of the previous exercises, and let's see if we can factor out some of these numbers. So with 500, I am going to factor out, I am going to factor out, let's see if we can we divide both of these by 4? Or maybe we could divide both of them by 2. We could use the calculator really quick. And it looks like they're both divisible by 4, and we want cube numbers. So even if it can be divided by 4 and it gives us no cube numbers, then we should do 2 if it will give us cube numbers. So we want the one that gives us cube numbers. So divide 500 by 4, and that's going to be 125, which 125 is a square number. A, so I don't have any A's that I can take away from both of these, so that's probably going to be as far as we can go with this. And let's see, we have our sum of cubes right here. So 125 is a cube number, A to the 3 is a cube number, and 1 is a cube number. So all of these terms inside our bubble are all cube numbers. So we're going to have to use our rule now. So let's go ahead and identify our A and B values. So let's take the cube root of 125, which again is 5 times 5 times 5. So that would be 5. And we have 3 A's, but if we take the cube root of 3 A's, that would just be 1A. B is 1. Because 1 times 1 times 1 is still 1. And there we go. So let's go ahead and move this down. So don't forget the 4. 4 stays there. And let's go ahead and get our A and B. So that's this part here, A minus B. So our A is 5A. So 5A minus 1. And now let's go ahead and work on the trinomial part, which is this part here. So let's see, A square, that's the one we're looking for. So this would be 25A square minus 6, oh, sorry, wrong one, A times B. So A times B, so 5A times 1 is going to just stay 5A. And then B is going to stay, well, 1, because 1 times 1 is 1. And I think that's it for that. I don't think there's anything else we can do. Sometimes we could divide this out again using double bubble, but in this case, I don't think there's anything else we can do. All right, number 10. So 24 and 375 are not on the list. So we're going to have to find values on the list by dividing them out. So 24 and 375, what's the biggest number we can divide out of both of them? That would be 3. C, because they both have a C, right? C4, C1. So the most I can take out is 1, and then we have one of these for those. So I'm going to just take out 1. Okay, and let's see what we're left with. So 24 divided by 3 is 8. C3, and this cancels out, so we have none of those left over. 375 divided by 3 is 125. Okay. And there we go. So what are our values? The A value and the C value. Now in this case here, we're going to ignore this. This is not part of it. We're only looking at this part because this is the part that is the sum of cubes. 8 is a cube number, C to the 3 is a cube number, and 125 is a cube number. So we have a bunch of different cube numbers. So I'm going to go ahead and put A and B. I don't know if this is going to be a long one, but I'm going to leave some space down here to write. So A, so take the cube root of 8, that is 2. And don't forget the C, because we have to uncube that one, take the cube root of it. 125, take the cube root of it, you get 5. This is cubed, so we make it uncubed. There you go. So 2C and 5D are the two terms that we need. So let's go ahead and bring this back, but I'm also going to need this 3CD because it's going to be the same thing. Don't forget to, don't just get rid of it. And here we have 8. Take the cube root of that, or actually here we have our terms. 2C minus our B value. So our B value is 5D. Now let's go ahead and get our trinomial portion. So A square. So we square this number. 2C, we square it. So 2 square is 4. C square is, well, C square. Minus AB, so that means we got to multiply both of these together, so that'd be 10, because 2 times 5 is 10. C times D is CD plus B squared, so that's 25 D squared. So again, square this number, so 5 times 5 is 25, D times D is D squared. And there we go, so we got all of them sorted out. Not so bad. Okay, so let's go ahead and move on to the third one. And I think there's 4, let's see. Yeah, I think this is pretty much it. There's only 3 more ways of factoring. So that's difference of cubes, trinomials, 4-term, and we have a second page of 4 terms. So anyway, this is different because the other one was a sum of cubes. Sum means add. Difference means subtract. So we are subtracting a cube number from another cube number. And here we have our rule again. You will need the rule. That's not on the worksheet. So let's see what we can do. So let's identify our A and B value. Oh, actually, we should check to see if both of them are E. Yeah, we should check to see if both of them are cube numbers. So X is a cube number, and don't forget 1 is a cube number as well. So I'm gonna go ahead and Oh, sorry, identify our A's and B's. Sometimes you can get away without using it, but I would recommend it because a lot of times I notice that people will forget their A's and B values, or they'll square the wrong number or take the cube root of the wrong number, so it's best to identify them. So the first term, A, so that would be X. We just replaced it with X. And B is 1. In this case, ignore the negative. Okay, that negative is part of it. But don't forget that -1 times -1 is +1. So in this case, when you're using the formula, ignore the negative. Okay, so let's go ahead and put them in. So X, and it says to minus, so -1. All right, and then we have the trinomial portion of this. So A square, so take A, which is X, square it. And let's see, A times B, so this would be plus X plus B squared. So B squared is 1, so we end up with something like that. All right, that one was a super easy one. Makes me almost a little disappointed, actually, of how easy it was. The only reason I'm a little bit, I wish it wasn't so easy, was because like you don't really learn much from these easy ones. But in this case, at least we learned one thing, and that is to place numbers in the right spot. But we kind of already knew that. So let's go ahead and move on to the next one. So 216 is a square number. 125 is a square number. K to the 3 is a square number. So we have cubes. They're supposed to be cubes, not squares, cubes. All right, so let's go ahead and identify the A and the B value. So A and B, so A is the first term, and we take the cube root of it. Since I have this list in order, that's 1, 2, 3, 4, 5, 6. And we could get our calculator and times 6 times 6 times 6, and we should get 216, just to check it. And let's see, don't forget the K. So when you're looking at these A's and B's, you're talking about the whole term. This whole thing is your A value. And for B, we only have one number, that is 125. So that's going to be 5. Because 5 times 5 times 5 is 125. All right, so let's go ahead and put this together now. So we have A minus B, so 6K minus 5. A square is, let's see, so 36 square, K square. A times B, so 6 times 5 is 30, K. And this one's kind of a weird one because they're both plus. Make sure you get the pluses and the minuses, because I can already kind of tell right now that might be a little confusing, because I can kind of, okay, so pay attention. This one's minus, plus, plus. If I go back to sum of cubes, it's minus, minus, plus. So those signs do make a difference where they are placed. Again, they look very similar if I switch back and forth. You may not even notice that there's been a change. So yeah, be careful with those. And then 5 squared is 25. And that's it. We're done with this one. That is factored out. Moving on, 4 is not a cube number, and 32 is not a cube number. So this means that we must factor out something. So let's see, 32 and 4, what two numbers can they be divided by? Or what one number can both numbers be divided by? I mean, we could go with 2, so divide both of them by 2, and you'd get 2 and 16. But 2 and 16, neither of those are cube numbers. So we're going to have to go with 4. So I'm going to go ahead and take out 4. And that would be 1 minus, and 32 divided by 4 is 8. H to the 3. And check it for cube numbers. 1 is a cube number. 8 is a cube number. So they're both cube numbers, and h to the 3 is a cube number. All right. So, since we know they're both cube numbers, let's go ahead and use our rule. So, oh yeah, let's go ahead and identify our A and B. So A is the first number cubed root, cube root of the first one. So that'd be just 1, because 1 times 1 times 1 is 1. 8, let's see, that's the second number, so that would be 2. But again, 2 times 2 times 2, and 2h. All right, so a to the 1, or sorry, a value is 1, so this would be, all right, we're on this step right here, a minus b. So 1 minus 2h. All right, so a square here. So now we're on this trinomial portion, so let's go ahead and square 1. All right, didn't get much out of that. Plus a times b. So 1 times 2h is 2h. And b squared. Okay, so this looks like the only one we're going to have to do a little bit of work on. 2 times 2 is 4. H times h is h squared. And that's it. I think we are done with that one. Let's move on to the next one. So we have 2x to the third minus 54y to the third. Okay. So I have two cube numbers. Well, actually, 2 is not a cube number, and neither is 54. Maybe we were thinking 64. So I'm going to divide both of them by 2. So that would make it x to the third minus, and then 54 divided by 2 is 27. And I think that might be it. Yeah, there we go. So this is a cube number, and this is a cube number. So let's go ahead and get our a and b values. So a and b. So we're only looking at this part here, this binomial. So if we uncube our first term, that would just be x. 27 again is a cube number because it is 3 times 3 times 3. So in this case, don't forget the y as well. So that'd be 3y. Not bad. Now let's go ahead and put it together. So don't forget the 2. The 2 is part of the answer. A minus b, so that'd be x minus 3y, because again, this minus that. Now let's get on to the trinomial part of it. So a square is actually going to be x squared plus a times b, so x times 3y. And don't forget to put them in alphabetical order, so it's going to be 3xy, alphabetical order, plus b squared. So this would be 3y, and we square it. So 3 times 3 is 9. Y square that, we get y squared. So there we go. That's our factored solution here. And that's pretty much it. Okay, so I only have 3 more slides to go. I'm not sure if we can cover all of this today. Anyway, I guess we'll go ahead and just go through with it. So trinomials, this one should be kind of hopefully easier because, well, we've already kind of covered trinomials, but this is kind of a lot to throw out on in one day. Let's see what the homework looks like on this. Okay, I guess we'll just keep going. So trinomial, so again, you're going to use your reverse FOIL technique. So I need two numbers that will multiply to the last. So I'm going to start off with the double bubble. Think of two numbers that will multiply to your last number. So 24, and you can come up with a lot of numbers too, right? So you can come up with 2 times 12, 3 times 8, or 4 times 6. Wait, did I already say 4 times 6? No, I said 2 times 12. So we need both of those numbers to add up to 2. So 2 and 12 will add up to 10. Oh, and don't forget the signs too. So remember, this sign means that they will be opposites. They will be different. So one will be plus, the other will be minus. So this means I have to subtract one from the other. So 12 minus 2 would be 10, or 2 minus 12 would be negative 10. So neither of those will give me 2. We could try 3 and 8. So 8 minus 3 is 5, or 3 minus 8 is negative 5. Neither of those give me this middle number I'm looking for. But we do get one from 6 and 4, because 6 minus 4 is 2, and that means this is the combination we are looking for. 6 minus 2 is, 6 minus 4 is 2. And then we need our first number. So again, we took care of those, and our first number is going to be n square, n square. And let's see. I think we're not quite done with this first one, because n square minus 4 is a difference of squares. So difference in squares, remember, first square number is a square number minus another square number. And we use this rule, which again should not be a big surprise, because, well, if you use FOIL, you would still get the same answer. So this part is going to change, which means this first part here, there's no such thing as a sum of squares, so we cannot do anything with this. But for this, we can do something. So if we use our rule, n, and this means that they will be different, and take the square of both numbers. So 4 square is 2, n square, take the root of it, we have n. So there we go. We now have it factored all the way. So always check it, okay? Always check your work. Make sure that there is nothing else you can factor, because if we stopped right here, it would not be factored. So you have to look at both or everything and see, okay, can I factor anything else? All right, continuing on, let's go to number 16. So here, if we try using our double bubble, it probably won't work out, because I have here w to the 3, and I would need two numbers that multiply to 20w. And it's not impossible. Actually, looking at it, I think you can do this. But let's keep it simple, and we're going to factor out w from all of them. So they all have a w. So each of them have to give me one w. So w squared plus w minus 20. And he has no more w, so it's all gone. So we have one less w for everyone. But this should allow us to factor it out. So starting off with our last number, I need two numbers that multiply to negative 20. And remember, the only way to multiply to get a negative is if you have a positive times a negative. Because negative times negative is positive, and positive times positive will give you a positive. Yeah. But now I need two numbers. So two numbers that if I take one and subtract the other, I get 1. So with 20, we have a couple of options. Remember, we have 1 times 20, 2 times 10, and 4 times 5, which these have a difference of 1. So that is likely going to be our match. But since one is negative, we need one of them to be the right one. So again, the hint is the bigger one matches the sign of your middle term. So 5 minus 4 is 1. But if I put 4 here and minus 5, 4 minus 5 would be negative 1. All right, so there we go. We took care of our outside and inside. Let's work on our first number. So w squared, if I unsquared, it would just be w. And in this case, again, look around, look for anything else you can do, because sometimes they will trick you. They will make you use 2 methods instead of 1 method, which in this case, I don't see any sums or difference of cubes or squares or anything else like that. So I think we're done with this one here. All right, number 17, same thing here. It looks like we're going to have to factor something out. Anytime you have an a value, that makes it a lot tougher. So if you can get rid of your a value, which in this case, 2, 38, and 68 are all divisible by 2. So let's take 2 out. Oh, and you know what? They also all have an a. I think you can factor it out and still get the right answer like this, but again, I would prefer to just take out any greatest common factor so that you can make it easy on yourself. So let's go ahead and do this. And here you get a more regular trinomial, so it's a little bit easier to factor. 38 divided by 2, so that'd be, what is 38 divided by 2? 19? I think it is 19. 68 divided by 2, so that would be 34. Okay, now look at this and see if we can factor it. Now be careful, because I think, I don't know if it'd be on this assignment, but sometimes you will get trinomials that you cannot factor. Like, think of any of the types that we've had to use quadratic formula on. All right, 2a, and then let's go ahead and bring out the double bubble. So last number, I need 2 numbers that multiply to 34, but will add to 8. And again, if you're not sure about that, take 34 and factor it into as many numbers as you can. 34 divided by 2 is 17. Which 2 plus 17 is 19. Oh, and don't forget the signs. I always tell people, watch out and do the signs first, because now you know if you're going to add or subtract or anything like that. So I know if I add this number to that number, so 2 plus 17 is 19. So I know 2 and 17 are the numbers I'm looking for. Put in your a, so that way you have your first term here. And that's it. We're done. Okay, that was actually a pretty easy one. Okay, here we have, it looks like all of them have x. So let's go ahead and take an x out as our first step. So there we go. Oh wait, hold on, double check it, make sure we took only one x from all of them. And that seems to be the most that we could do here. Since we have a trinomial, let's see if we can factor something out. And let's go ahead and start with this here. So what 2 numbers can I multiply to get 25? That will give me 24. Now this one should be kind of an easy one, but again, I always tell people to look for the signs first. So one is positive, the other is negative. So this means that we are subtracting one of the numbers. So this makes it a little bit easier because we narrow down our guesses, because the only number is 1 and 25. 1 times 25 is the number that gives us 25 like this. And don't forget the sign also. 1 minus 25 is negative 24. Now, this one's a little bit of a tough one because this x squared is a little bit different than some of the other things we've been working with. But let's see, we have an x, we can't just use x and x, okay? Because we need two numbers that multiply to 4. So that'd be x squared and x squared, because x squared times x squared is x to the 4. Now, this might be something a little different. You might have x to the 1 times, say, x to the 3. But if that was true, well, if you were to test it, it wouldn't work out. So you test it really quick, and this is something I recommend that you do all the time. X squared times x squared is x to the 4. Negative 25x squared plus 1x squared is negative 24x squared. So everything seems to be working out pretty well. But there is one more thing, and that is we have a difference of squares. Difference of squares here. So that tells us we're probably not done yet. Okay, so x squared minus 1 and x minus 5. Oh, wait a minute. Sorry, that's supposed to be 5 here. So we have to unsquare it. So x plus 5, x minus 5. There you go. So unsquare that, unsquare this. Okay. Moving on to number 19. And I'm going to go ahead and use the AC method. So for AC method, you multiply this times that. So again, you give, but you got to take it back. So 3 times 5 is 15. And we use this just for factoring. So let's see what I can get by factoring it out. So I need two numbers that multiply to negative 15. So that means one is positive, the other is negative, because that's the only way to get a negative number when multiplying. But it also means we're going to subtract one number from the other. Now, there's kind of a hint that you can use, I guess a hint is the best word. But the bigger the middle number, so in this case, my middle number is much bigger than this number. Or I should say, not as big, it's not big. But like if you look at this one here, 2 is small compared to 24. W by itself, so this W and 20, or 1 and 20 are far apart from each other. When these two numbers are far apart, that means that you're going to have close factors. If you have numbers that are far apart, like in this case we had 34, so 34 and 19, so that they are a little bit closer, but that means that they're going to be a little bit close like this. Factors are going to be close. When they're really, really close, that means the factors are going to be really far. So that means 15 and 1 are the factors. And if you don't understand that well, that's okay. Just go back to making a list and it'll still work. But it's just something that kind of, once you notice, it makes it a little bit easier to find factors. X squared, x squared. And now check these again. Make sure there's nothing else you can do, which actually in this case, there is something we can do. That is to a difference in squares. I have a difference in squares here, so let me rewrite this. So remember, a difference in squares, we have a double bubble, and I'm going to split this part here. I'm going to split it into 2. So one is positive and the other is negative. So 1 is a square number. Be careful, because that is a trick that they always try to pull on you, is that 1 is a square number. Okay. And it looks like we're on the last one for this one. What is going on with this one here? Now this is actually a perfect, what do they call it? Perfect square trinomial. This is a special case. I don't think we've gone over it in this one here. But if you remember converting to vertex form, you're going to basically use the same thing. And I know we use it in converting to vertex form, but a perfect square trinomial is, again, something like this. So, but I think we can go ahead and we can use our regular formula for this one here. So two numbers that make 4 when you multiply them. And again, this means that they will be the same, and they will be the same as whatever the first one is. So don't forget, -2 times -2 is still +4. Okay, and now we need the outside inside. So I need two numbers that will, well, okay, these will not add to the middle number because we have an a value. So we can't really use this. I mean, you kind of can, but we're gonna have to use a solve by trial. But let's just try, because I mean, looking at this, I kind of know it's a perfect square trinomial because the n numbers are square numbers. So 9 is a square number. So m to the 4, that means m to the 2 here. And let's check it really quick. So 3m squared times 3m squared would be 9m to the 4. Outside is 6m squared. Inside is also 6m squared. So they're both negative, so it makes -12m squared. 4 is what you get from -2 times -2. So I think we are done with this one, and that is pretty much it. We're going to move on to the last type of exercise. This is a bit of a longer lesson. I think I'm going a little bit over my usual time, but hopefully we can cover all of this. So let's move on to the last two. So how you do a four terms. So here we have 4 terms, right? So what you do is you group the first 2 together and the last 2 together. Now there is a bit of a trick on this. And let me go ahead and use that. So that would be, we're gonna make a group. All right, so imagine that this is a group and this is a group. What we're gonna do is we're gonna take numbers from both of them. So we're going to factor both of them with reverse distributive. So in this case, I'm going to look at this first group. What can I take away? Okay, so they both have x. But not only do they both have x, but they have 2 x's. So if I take an x squared from this guy here, he's only left with 1. X squared divided by x squared is going to be 1. Now here's the tricky part. This is the part that is super tricky. If your second term has a negative, you've got to make that first term negative. So what you're trying to do is you're trying to make it look like this. You're trying to make it look like this. So negative, so I'm going to factor out a negative, -4. There you go. Now I took out -4. So -4 divided by -4, that's 1. That leaves the x. -4 divided by -4, that's also going to be 1. But since I took the negative out, it's going to be +1 also. And again, this is the part that I'm telling you to watch out for, because you need this to match this. Those two match. And they match because in a way they are the same number. Okay, it's the same number. So what you got to do now is put this and this together. So x squared minus 4. And these two, x plus 1 and x plus 1, are going to be the same. Again, they're the same because they are actually the same, like, they are actually the same group. They are the same thing. And in this case here, we would be done normally, but in this case, I noticed that we have a difference in squares. So I'm going to unsquare and unsquare this one here. Again, be careful because this is a difference in squares. So x plus 2, x minus 2. So those are the rules on how you factor a 4-term polynomial. You use grouping. All right, here we go. So let's go ahead and use grouping here. So split it into 2 groups. Look at this first group here. What can I take away from both of them? I can take away x squared. All right, so there we go. Basically the same thing we did in the example. Now this one does not have a negative in the front. So it'll be a plus. And they both have 9. So I'm going to take out a 9 here and a 9 there. So group it, x minus 1, because 9 divided by 9 is negative 1. Put them together, x squared plus 9 and x minus 1. And again, always look at these, make sure there's nothing else you can do. Can I do anything with this? The answer is no, because there is no such thing as the sum of squares. Only difference in squares, difference of cubes, and sum of cubes. Those are the only two that, the only 3 that you have that are really special cases. So anyway, yeah, that's as far as we can go with that one. So let's go ahead and do this one. Break the first 2 and the second 2 into groups. The first 2 terms and the second 2 terms. So in this case, they both have a k, so I'm going to take away k from both of them. And let's go and do this one here. So k, let's see what we have left. K, and we took 2, take 2 from here. And there you go, k plus 5. Now let's go ahead and do this group here. Now again, be careful because this is one that you got to be careful with. If you see a negative on the third term, that means you're going to have to take out a negative. So in this case, I cannot take anything out. K and 5 have nothing in common. So if I take out the negative, that's going to make k positive, and 5 is also going to be positive. Okay, and it looks like we're ready to go on to the next one, k squared minus 1. So I'm going to put the outsides together. The 2 matching ones, k plus 5 and k plus 5, I'm going to put them together so that there is only 1 k plus 5. And now I always tell you to make sure you look for anything that is, make sure to look for anything that is, that you can do more with, okay? So in this case here, we have a difference of squares. A difference in squares, k squared minus 1. The 1 is a square number, so again, they're always going to try to trick you with that. So this means I'm going to break them into 2 groups. So I'm going to move k5, or k plus 5 over here. And let's see, k, because I unsquare it. 1 is a square number, plus and minus. There you go, so that was the rule. And there you go, so we have it completely factored. Let's go ahead and move on to number 23. So let's see, again, break them into groups. So if your third term has that negative, again, that's going to make it kind of tough. And don't forget, terms always include their sign. So positive 4v to the 3, negative 5v squared, negative 16v, and 20. So don't break this. What I'm expecting is someone's going to break it like that or break it like this. So again, you go by terms. Remember when we was talking about terms, I was saying that you should circle them if you're not sure what a term is. But let's go ahead and continue. So let's see. First group I have is V. So I cannot take any numbers out of both of them. So I'm going to take V square. So that'd be 4V minus 5. Now this is a hint, okay? This is a hint. Usually the first one is easy, 4V minus 5. This means I need to take away something from the second group to make it 4V minus 5. What can I take out to make this minus? So the other hint is that your signs are different. Negative, positive, positive, negative. This is the clue that you're supposed to take out the negative. And it has to go to 4. So 4 times 4 is 16. 4 times negative 5, or well, negative 4 times negative 5 is positive 20. So that is a clue that you're supposed to take that number out. So again, you need this group to match that group. V squared minus 4. So I'm going to put this and this together, and put this and this together. Man, these examples are brutal. None of them just let you chill, because this one here is going to make me do some more work. V squared minus 4. So I'm going to have to factor that, because that is a difference of squares. So unsquare V, unsquare 2, and they are different, which means it's subtracting, but it also means that they are different. I don't know why I put that little thing up there. So plus and minus. There we go. And let's do this last one here. So I'm going to go ahead and group it again. And let's see, take away what we can do. So again, factor by reverse distributive. So I can take 2 out of here. I can also take 4 x's from both of them. So let's see what we're left with in this case. We're left with x, and let's see, 18 divided by 2 is 9. Oh, and I don't have anything else in there because there were 4 x's, but we took them all out. Now again, if this is a plus, then you don't have to worry about it, okay? But if it's a minus, that's the one you really got to worry about. So divide both of these by 7. And again, these two groups should match. If these two groups do not match, you need to try again. 2x to the 4 plus 7 times x minus 9. And it looks like we're done. There is actually nothing much else for us to do. So that's it for the exercises, but let me go ahead and let you know a few things. So oh, come on. My computer froze. All right. Anyway, that is all I have for you today. I will see you next time.